Okay, so our next task is to actually, so we've seen how to actually throw a scatter plot together. We want to actually know what to put where on our scatter plot. And this is where dependent and independent variables become important. And the idea is that our dependent variable should be dependent on our independent. And this is why we say cause and effect. So the idea is that your weight is dependent on your height. So as you get taller, your weight has to increase. Now that doesn't mean that you can't have heavy short people. It's around the short people when they were shorter, hopefully weighed less. So when we're looking at a dependent or an independent variable, the way we plot them is our dependent variable on our y-axis and our independent on our x. And the reason for that is when we're doing those correlations and we're looking for an increase, we want to say that whatever is on our y-axis, the change in y-axis variable is caused by whatever's on our x. So if we have a positive relationship, we're saying, well, as whatever is our dependent variable increases, it's caused by the independent variable. So let's have a look at a couple of examples. So if Madison wrote down the length, the genre and length of each song in her playlist, in terms of the length of a song wouldn't determine the genre, but the length could be determined by the genre. So the length might be dependent, I'll just go dv, the length may be dependent on the genre. Caven records the amount of fertilizer, so our variable's amount of fertilizer used and how tall his plants grow. So the height of the plants isn't going to cause more fertilizer, but having more fertilizer may increase the height of your plants or decrease it if you feed too much. So the height of the plants is likely to be our dependent variable, and the amount of fertilizer is most likely to be our independent variable. Ella measured the height and number of leaves of each plant in her laboratory. So she's measured height and number of leaves. Now, a high plant, so the taller a plant is more likely to cause more leaves as opposed to a plant having more leaves making it high. So we would say the height is likely the independent variable, so the causative variable, and the number of leaves is the dependent variable, because the height is generally speaking going to be dependent on the number of leaves is likely to be dependent on the height. Okie doke, our third topic. We want to determine the line of best fit. So we've talked about correlations and how we could draw a line, but we haven't looked at how to do that. And we want to do that by eye. And we're also going to use technology to determine and create lines of best fit. So we're going to use an example to work through this. So Liv is working in a cafe and has suspected that there was a relationship between outside temperature and her sales of hot chocolate. She's recorded the data in the table. So the first thing we're going to do is try and work out what's our dependent and independent variable. Is the number of chocolates sold going to cause the temperature to change? Probably not. But if it's a hot day or a cold day, that could change the number of hot chocolates. So the number of hot chocolates is more likely to be dependent on the outside temperature. So now that we know what's dependent and what's independent, we can label it on our graph. So we're going to have temperature degrees Celsius, and we're going to have number of chocolates sold. Once again, we're going to set up our axes. So with our temperatures, it ranges up to 20. So I might go up in 2s this time. And then our number of chocolates goes up to about 20. So we'll do the same. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Let's start plotting. So 20 degrees, we sold none. 18 degrees, we sold 1. 10 degrees, we sold 8. 11 degrees, we've sold 6. 13 degrees, we've sold 7. 10 degrees, we sold 7. 11 degrees, 10. 8 degrees, 13. 9 degrees. Come on. 9 degrees, we've got 9 degrees, we've got 14, 4 degrees, 8, 6, 4, 2, 1. 4, 0. 4 degrees, we have 16. 2 degrees, we have 18. And 1 degree, we have 20. Okay, so from our data, it looks like there is a negative correlation. As the temperature increases, the number of chocolates sold. So we have a negative correlation. We have got, it looks like a fairly linear relationship. And on the surface, I think that looks like a relatively strong linear relationship or a strong correlation. So to determine a line of best fit, a common way of doing that is to look at what is the average of our X and average of our Y. So what we do is we're going to say, well, we want to look at what is the average of our outside temperatures. So it's the sum of all of our X over our number of samples. So it's going to be 20 plus 18 plus 10 plus 11 plus 13 plus 10 plus 11 plus 8 plus 9 plus 4 plus 2 plus 1 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 over 12 samples. I'm just going to jump on my trusty calculator to add these up. So I've got 20 plus 18 plus 10 plus 11 plus 13 plus 10 plus 11 plus 8 plus 9 plus 4 plus 2 plus 1. So I get 117 divided by 12. So 9.75. So I've worked out the average of my independent variable. Now I'm going to do my dependent variable. So we do this exactly the same way. So we have a 0 plus 1 plus 8 plus everything. And we should have the same number of values, 12. And don't forget, when we're counting our number, we include the 0 as 1. So it's still 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But we do, obviously we don't have to add a 0 in. Plus 7, plus 7, plus 10, plus 14, 16. So I have 120 over 12, which is 10. So I've got an average x of 10 and of 9.75 and an average y of 10. So I go through and I mark that on my graph. So I've got 9.75 and 10, which gets me to about there. And I can use that as a point on my line of best fit. I've done that adding up right. I'm just going to recheck my number. It seems a little bit low. So 20 plus 18 plus 10, 11, 13, 10, 11, 8, 9, 4, 2, 1. Yep. So usually what we'll do is we'll use that as a pivot point on our line to try and get a line of best fit. I mean, normally by eye, we work on getting half above and half below though. So if I was doing by eye, I would usually say, well, for me, that's probably my line of best fit because I've got half my points above my line and half my points below the line. The mean value, so taking this mean of your x and y is, I guess it's one method of trying to get that average point in there. What I want to look at next is how to do this using technology. So to use technology, we're going to switch over to Microsoft Excel. So to do a graph in Microsoft Excel, what we need to do is have some data, and we always put our independent variable in our first column and our dependent variable in our second. So our first one is our outside temperature and number of sales. So 20 and 0, 18 and 1, 10, 8, 11, 6, 13, 7, 10, 7, 11, 10, 8, 13, 9, 14, 4, 16, 2, 18, 1, 20. So double check my numbers before, remembering how we use Excel to check. Average. How about that? Oh, I'm going to switch back. I can see my mistake, why it didn't work out. So 10 is here. So it actually went straight through my line of best fit, which is what we really wanted to happen. So we'll switch back over to Excel after I've found my error before. I'm feeling very happy about that. So once we've got this data, Excel will actually create our line of our scatter plot and a line of best fit automatically for us. So if I go Insert and Scatter Plot, now the important thing is when we're looking at these scatter plots, we don't want ones with lines because you can see on the Excel how it puts, I guess, squiggles everywhere, which isn't going to be very helpful. So we just want the dots. We can hit a little add and put in the other parts that we want. So this is the number of hot chocolate sales. This is the outside temperature. Let's see if I can pop in the degree symbol. Try and make this look proper. There we go. Insert in degrees Celsius and pop our title on, which is sales of hot chocolate versus outside temperature. So with our graph, we've got our lovely scatter plot there. We can see our relationship. We can now click on any point, hit our add, and request a trend line. Now the default trend line in Excel will be a line, which is very helpful to us. We can also get Excel to tell us what the equation of that line is. So if we, usually we can just double click on the line, or if we're in our trend line, we can go format trend line, and we can scroll down and we can say, you know, show me the equation on the chart, and it'll actually take some work out and work out, well, what's the actual relationship that's there. So that's our exercise for today. Make sure you go through and do all your exercises in your homework and your quiz for the week. That's very important. So you don't need to submit specific work other than your quiz. Have a fantastic week 2 of remote learning, and I look forward to seeing you all as soon as possible and at our Zoom session next week.